The name is wrong. It's not artificial intelligence. Intelligence would involve consciousness. From the Gödel argument, you see, this is the plot which I think has got lost. Now, a computer is a very specific kind of mathematical structure. It means computational mathematics. It's a very limited part of mathematics. I don't think they will ever become conscious by virtue of being computers in our current sense of the word. But I think consciousness, it's not computational. That's still true with AI. You talk to an AI thing, it doesn't know what it's doing. Computers have got so powerful that they've lost the thread of what they're doing. I think the point has got lost. I think Turing wasn't too far off. I think people have lost the plot.
A few times you talk about the Nobel Prize. We're back from Stockholm. This year we've been there interviewing Nobel Prize winner. Don't you think that this year Nobel Prize is the tribute to the Nobel Committee for Artificial Intelligence? Nobel Prize in Physics, fathers of AI. Nobel Prize in Chemistry, Sir Demis Hassabis, co-founder of DeepMind, that's AI system. David Baker, computer vision, digitalization of proteins. Don't you think there's a tribute for AI?
I see. Well, you have to be careful. First of all, the name is wrong. It's not artificial intelligence. It's not intelligence. Intelligence would involve consciousness. And I've always been a strong promoter of the idea that these devices are not conscious. And they will not be conscious unless they bring in some other ideas. They're all computable notions.
But intelligence, it's not consciousness.
It depends on consciousness. You see, well, it depends on how you use the word. I think when people use the word intelligence, they mean something which is conscious. I mean that. You see, I developed my own ideas after going to a course. You see, when I was a graduate student in Cambridge, I went to 3 courses which were nothing to do what I was supposed to be doing. One was by Bondi on general relativity. One was by Dirac on quantum mechanics, very distinguished Paul Dirac. And the third subject was on mathematical logic. And I learned about Turing machines and the notion of computability. And I knew what computability meant. And I learned about Gödel's theorem. And Gödel's theorem I found stunning because it told you that there are things that the understanding transcends the use. Let me put that more clearly. What Gödel does, it's very clever, what he does is to produce a statement. Now suppose you're trying to develop your mathematical methods of proof. What do you mean by proving a theorem in mathematics? How do you know it's really true? Well, you prove it. What does proof mean? Well, you see, does it mean, okay, you've got a set of rules, and if you follow these rules, that makes it a proof. Mm-hmm. Now, how do you know these rules only give you truths? Well, you've looked at them carefully and you say, oh,
but
yeah.
Maybe AI creates its own rules.
No, you see. You have to be careful about this. This is the point. But I learned from Steen. This was a man called Steen, who was a logician. And I learned from him this important thing about Gödel's theorem. Now, Gödel's theorem is extremely clever. You make a statement which asserts that it cannot be proved by these rules. It's just, the clever thing is to make it do it. It says, you give your rules, which you regard as the rules of proof, and you could put them on a computer. So that means they're computational rules. Now, I knew that there were things that you cannot put on a computer. I learned from this course that there are non-computable things. There are things in mathematics which are not computable. Now, what does computable mean? It means that you can make a computer. Well, you have to define what a computer is. And Turing had one definition of a computer. There were several other, Church and Curry, other people had their definitions of computing. They all turned out to be equivalent. So there is one universal notion of computability, which is what you mean by what can be done by a computer.
But maybe this is only language problem, that the language development has not kept out the development of AI. Maybe we have just only a language problem, that we cannot, describe what we created.
No, I don't agree with that. It's not a language problem. You see, you make your new language. Sure, you can do that. You make your new language. And that's what you can do. See, let me describe the Gödel theorem, how it works, you see. See, the Gödel theorem says you construct a statement which says, you see what it means. The way you've constructed the sentence, you can see what it means. And what it means is, I am not provable by those rules. And it does that. It really says that. Then you see, okay, well, perhaps it is provable by the rules. If it is provable by the rules, then it must be true. Well, I've said it the wrong way around. Doesn't matter. The other way, suppose it's false. Then that means it's provable by the rules. And if it's provable by the rules, you've understood the rules, you said, you looked at them all and say, yes, that's okay, that. Sure, if you follow those rules, it is true. So that means you believe that the rules only give you truths. So therefore it is true that it's not provable by the rules. If it's false, you see, then it is provable by the rules, and therefore it's true. So it has to be true and not provable by the rules. I found that amazing.
But still I don't understand why AI cannot create its own rules.
Because it doesn't know that they're true. You see, that's the whole point about the Gödel theorem. The whole point, as far as I'm concerned, about the Gödel theorem is, how do you transcend the rules? And that's what you do, by understanding them. You understand them why they're true. It's not that you use the rules, but you understand why use of the rules only gives you truths. And that's how you can prove things which go beyond the rules, by knowing why they're true. Now, knowing why they're true, well, what does it mean? Well, it means you understand them. What does understand mean? You've got to be conscious of them. You see, the wording is clear. It means that you have to know what you're doing. You have to know why they're true, not that they're true. You can be told that they're true. You can learn at school that they're true. That's not the point. You have to know why they're true. Why they're true needs understanding them. And understanding them requires to being conscious of them. Now you see, the point I was making is that consciousness enables you to transcend the rules. You see why they're true, and that goes you beyond it. You see, what the Gödel theorem does, it tells you how to use your understanding of why the rules are true to transcend the rules.
You think that AI is the simple tool or simple thing that we can use in the single case?
No, I don't say it's single. It's obviously infinite. No, clearly, that's not the point. The point is it doesn't know what it's doing. That's still true with AI. You talk to an AI thing, it doesn't know what it's doing. It speaks from experiences, if you like. You see, people have confused the story. The story is they've lost it in the power of computing. The thing is that computers have got so powerful that they've lost the thread of what they're doing. They're computing.
Do you regret it, that it's so power?
Well, it's losing the point. You see, I think the point has got lost. I think Turing wasn't too far off. You see, he was a little bit confused person in a way, because it was not clear what he believed. But he did call this thing the Turing test. How do you decide whether an entity is conscious or not? Well, you have a conversation with it. You talk to it.
Maybe AI is a new sphere of human existence.
No. It's missing something. I think, that's the trouble. You see, it's all... I mean, obviously it has a role to play. I'm not going to say that. Clearly it has a role to play. It has a role, but you mustn't be confused. The fact that it has a role to play, it's to do with the power of computation. Sure, computers have got so powerful now that they can do things way beyond what humans do in computing, sure. And you can take a mass of data and you can analyze that data and you can see what the data says and does this thing in accordance with previous things in the data or is it not? And AI, that's all it does. It doesn't understand what it's doing. And understanding is different from computing.
Because inside a black box, there is just only statistic. There's the simple statistic machine.
Well, if it's a machine, it's not conscious. No, I think people have lost the plot, yes. No, that's true. You see, I wrote my book, The Emperor's New Mind.
But what does it mean that people lost the plot?
Yeah, I think they've lost the plot. Because the whole point of my train of thought was, we've got to find something in physics. You see, I believe, I'm a physicalist, in that I believe whatever is going on in our heads, whatever creates consciousness, is part of the physical world. I don't believe it's magic that comes in from who knows what.
Black box, it's also part of the physical world.
But what do you mean by a black box?
We know what's at the input. We know what's at the output. But we have no idea what's deep inside. Yes, that's the black box.
Yes, but that doesn't help because you don't know what's inside. What kind of physics is inside that box?
Maybe new physics.
Yes, but new physics of a particular kind. What I'm claiming from the Gödel argument, you see, this is the plot which I think has got lost. What I claim is saying that the physics that is involved in conscious thinking has to be non-computable physics. Now, the physics we know, there's a little bit of a glitch here because it's not completely clear. But as far as we can see, the physics we know is computable. You see, what about general relativity, where we have wonderful machines which compute what black holes do when they spiral around each other and produce gravitational wave signals, and you can say, yeah, that is a black hole collision because this has this very clear feature, and yeah, you can do all that. That is fine, but that's not what I'm talking about. What I'm talking about is the physics has to be a physics which is, in principle, non-computable. So AI can go ahead as much as it likes. It's not going to be able to get this. You talk about a black box, but you don't know what's in that box. Is it a computer? Is it a computer of the kind we understand now? Is it something which involves a physics which involves a non-computable process? Not so far. I'm not saying that won't happen. I dread it because I don't want it to happen. I can't help it because I suspect it will happen someday. But it's not AI as we now know it. AI, as we now know it, is computer-driven. And that means it's not going
Superhumans, AI will never exist?
Well, the trouble is that AI is a bad term. It means artificial intelligence. Now, intelligence, in my view, is conscious. That's what intelligence is about.
Okay, so how I can call it?
Artificial cleverness. How about that? AC. You can see the difference. To some extent, when you do mathematical, you have mathematics students. Some of them understand what they're doing, some are just clever. They can repeat what they've learned. They know how to do it very cleverly. They can calculate very well, but they don't necessarily understand what they're doing. The physics we don't know involves non-computability. So that's my claim. So I made this claim in The Emperor's New Mind. And I've made it a little bit more forcefully in Shadows of the Mind.
I mean that maybe it's not the consciousness. Maybe it's something absolutely new. Maybe that's not awareness.
But there may be completely unknowns which we have no concept of at the moment. That could be true. I'm talking about things. You see, if you're talking about AI, that means, unfortunately, it's a bad term, because it says artificial intelligence. Whereas to me, when people use that term, they mean things that can be done by computers. That's what they mean. They have computers, and their computers are very powerful. And then what they mean by AI is using computers. It may not be using in a straight logical way. Usually, I haven't studied these things, so I'm probably out of date. But as far as I can see, what it is you look at masses of data, and then you sort of look for patterns, or you try to analyze it in that kind of way. But it's all computational. You're using computers. By its very nature, it's computational. The word means computational, means by a computer. Now, a computer is a very specific kind of mathematical structure. It means computational mathematics. If you study the mathematics as an abstract subject, you rapidly learn that there are things way, way beyond computability. It's a very limited part of mathematics. Some of the mathematics that's involved is not computable. You can't get at it by an algorithm. Now, you see, people often think, well, AI doesn't use algorithms because it's using these sort of random methods or something. I don't know. I haven't studied in detail what AI really, what is called AI, really involves when you put it on a computer. But it is being done by a computer, so it's still something computational. No question about that. I'm claiming that you want something non-computational. Now, you see, people tend not to believe this because they just think of computers and they don't know there are non-computable things. If you study the mathematics, the mathematical logic, you see that there are non-computable structures. The logic, the physics of the world could easily be non-computable. And my view is that, yes, it is non-computable. And that somehow nature has been clever enough to produce beings which can tap into the non-computable aspect of the physics. And they managed to do this using natural selection. I have no idea how far down the animal kingdom goes. Humans are certainly conscious. I believe anybody who owns a dog is absolutely convinced that dogs are conscious. I believe it. Cats, probably. Elephants, certainly. Way down, way, way down, probably. Octopuses, I'm sure. I don't know. Is a bacterium conscious? I have no idea. Is a frog conscious? Probably, yes. Is an amoeba conscious? I have no idea. I'm just speculating. I've no real reason for believing these things. But I think consciousness is something different. It's not computational. And the thing is that it's just people are so hypnotized, I shouldn't use a rude word like that really, by the fact that computers have got so powerful that, yeah, there's the answer. The computers are so powerful, we found the answer. It's just computers. I'm saying, no, it's not. The answer is something much more deeper than that. It's not more complicated than that, it's deeper than that. It involves a kind of physics which we don't probably know yet.
It's deeper because it's based on the quantum world?
It's beyond the quantum world. You see, the quantum world is still computable. What's not computable, as far as we know, there's a basic unknown in quantum world. The quantum theory is fundamentally incomplete. I call it even wrong in a certain sense, because it believes that quantum superpositions persist at all levels.
Maybe when we ever create the universal quantum computer, we can create a synthetic consciousness.
Maybe. Yeah. No, I have nothing against it apart from the fact I don't like it. No, I have nothing theoretically against that.
Do you agree with that year Nobel Prize committee when you look at the Nobel in physics for fathers of AI?
I haven't looked at the details of it. I don't know what they say.
For fundamental work under synthetic neutral networks for Geoffrey Hinton. Is it physics?
I'd be rather doubtful whether it's really physics. I'm not sure. You see, the Nobel Prizes, you might question some of their decisions sometimes. I would question a few of them. Maybe I would question this one. I'm not sure. You see, I haven't looked at it carefully. It depends exactly what they say. You see, it's a technological advance, I would say. It's probably making use of... I mean, is it a theoretical advance, or is it... I don't think so, is it? But I mean, the Nobel Committee normally doesn't give the prize for purely theoretical. I mean, it doesn't.
It doesn't, yeah.
You have to have a physical application of it. Yes. Now here, I'm not quite sure. I'd have to see what the wording is in the Nobel Prize to say whether I'm happy with it or not. I don't know.
My question to you is about this self-driving car. They are processing the hundreds of data. Maybe there is the consciousness. There is one of the way of AI development that we are using something like a digital census, collecting the numbers of data about the reality around.
I don't think they're conscious in any sense, but they could drive better than humans. That's possible. I don't know what the comparison is now. They certainly make stupid accidents from time to time, but so do humans. So it may be that they become more reliable than humans, and that may not be too far off, for all I know. I have no complaint about that. I don't think that's any indication that they have consciousness. After all, we have devices which already turn off the lights at certain times, and maybe they know better when it's getting dark and so on, or how to economize on the use of electricity and things like that.
How do you look at the AI development, and what's your prediction about the future of AI?
See, I don't really know what AI does these days, you see. So you're asking me a question outside my area of expertise. I would say an area of expertise has to do with whether these devices actually do what we do. I don't think they do, because they're not conscious. I don't think they will ever become conscious by virtue of being computers in our current sense of the word. I don't know if that's an answer to your question. It doesn't mean that they won't be better than us.
The biggest risk of AI development is?
I think there is a risk involved here. Part of the risk is people thinking that they're actually...
that there is a conscious.
They're conscious, yes. There might be an even more of a risk if they were conscious. You see, maybe one could understand what's involved in consciousness and develop some kind of device. I'm not calling it a computer, because in my view, it would not be a computer. It would be something else, some device which is conscious. And since I believe consciousness is a physical process, I don't think we understand it. I think it involves the collapse of the wave function. That's partly a negative conclusion from, I don't see it anywhere else. But the collapse of the wave function is very mysterious and involves certain retrocausal things, which are a little bit puzzling. I think the way that time works is not so clear when you're talking about... But there are certain things which are in contradiction, you almost say, with ordinary causality. It's not so much that they are, it's that you have to have different concepts of what you mean by reality. And there are two concepts which I've tried to separate from each other. One is classical reality, and the other is quantum reality. Now, classical reality is the sort of thing we normally talk about.
We can touch, we understand, using our senses.
Yes,
yeah.
But the main difference I'm saying is you can ask the system, say, if I take this glass, and I can ask the glass, I can say, hello, glass, what shape are you? And don't do it that way, but I say, okay, what shape is the glass? And I say, oh, it's got a round top, it's more or less cylindrical.
And that's the classical world.
It's classical reality.
Yeah.
Now, quantum reality is more like... Well, Einstein had a nice criterion. But he didn't call it quantum reality. I'm calling it quantum reality. This was, how do you know that the wave function is real? Is the wave function of a particle real or not? And a good example of this is the spin of a spin-half particle. Now, the spin of a spin-half particle is a quantum thing. Now, can you ask the system, hello system, which way are you spinning? It doesn't. It looks at you blankly and says, I don't answer questions like that. Ask me a different kind of question, please. The right thing to do is you say, okay, particle, is your spin in that particular direction? You see, the spin has an axis. Mm-hmm. The way that spin works, for a spin-half particle, it has a particular axis. That's how you describe the quantum state of a spin-half particle. It has one particular direction, and it spins about that direction. Now, can you ascertain that direction? No, you can't. It's quantum reality. You cannot ascertain quantum reality. You can only confirm it. So I like to use those two words, ascertain. I can ascertain the shape of this glass. That's classical reality. I can only confirm quantum reality. I can, if I think I know which direction it's spinning. I said, yeah, I've got my calculation done. I said, you've done this, blah, blah, blah. Yes, it's probably by now spinning that way. I say, hello, state. I think you're spinning that way. Have I got it right? And if I have got it right, it says yes with certainty. So that was Einstein's criterion. So if you can confirm with certainty that then it gives you an element of reality. He called it an element of reality. I'm calling it an element of quantum reality. Classical reality is the other kind. You can ascertain classical reality. You can only confirm quantum reality. And you need those two ideas, and you need to separate them. And quantum reality behaves very peculiarly. It actually behaves retrocausally, what you might think. There are these experiments with, I think you talk about the Nobel Prize, the one before that one, to Zeilinger and people about these, I think, EPR-type experiments. I can't quite remember what they got it for, but it's something like that. You have these effects which seem to affect the instantaneous. You see, you share a spin between Alice and Bob, and Alice and Bob originally have a spin 0, and their spins are opposite. So if Alice's spin is this way, Bob's is this way. Now suppose Alice measures her spin and she finds it to be that way. Retrocausally, along the past light cone, so it's not just simultaneous, it's worse than that. It's into the past, but not faster than the light could go from this one to this one. It's a strange way around. But retrocausally, it becomes the opposite of Alice's measurement. Bob can't ascertain it, so she can't send a signal faster than light because he can only confirm it. He doesn't know which way it is. So you need that idea to make sense of these EPR, Einstein-Podolsky-Rosen type experiments, which I think, I'd have to check exactly what the Nobel Prize was the year before this one. But I think it was to do with that. That's a very important and fascinating discovery. But to understand what's going on, I think the best way to do it is using quantum reality. And you certainly can't send a signal faster than light by these means, but you can retrocausal backwards faster than light, or not as fast, almost as fast as light, backwards, if it's only quantum reality.
As long as we don't understand how quantum world work, we cannot replace it into
I
the
think it's not
digital
as bad as that. You see, don't understand is saying, rather trying to put it into a classical perspective. We can understand the mathematics of it, and we can get used to it, okay? And that is involving an understanding. If somebody asks me a question, I may not understand it that well, but I could do my best, and I might understand the quantum mechanics well enough to give the answer that quantum mechanics would say. Now that means understanding. Sure, it's an understanding of what's going on. You know, there's this famous comment, was it? Nobody understands quantum mechanics, was that?
I know
maybe it was Bohr or somebody.
Bohr, I think
it was Bohr, yes.
Yeah.
No, you see, I think that's misleading. You see, understanding doesn't require it to be a classical understanding.
We are determined by the nature to understand the classical world. Quantum world is indeterministic and it's ununderstandable for our mind a little bit. You need to use the formulas to try to understand the quantum world.
I think it's unfortunate to use the word understanding and limit it. You can say, I don't know what word to use, but if understanding in the sort of classical sense, and that fails. Yes, that does fail. But it's not a lack of understanding. You get the picture, and you can see, oh yes, I know how to make the predictions in quantum mechanics work, and they can be quite yes/no predictions. Some of the predictions don't have to be just probabilities. So I think the view is it gets sort of mixed up with the idea, oh, you only know the probabilities or something. I think that's misleading. These things are puzzling not just because they're probabilistic. They are sometimes just probabilistic, but that's what makes them consistent by having them only probabilistic. But the things which I find most fascinating about quantum mechanics are not probabilistic things. They're like these EPR effects. Sure, it's probabilistic if you ask somebody to make a measurement and it's only a quantum reality that he's trying to make a classical reality measurement. He's only going to get a probability answer. I just think one has to separate the quantum reality from the classical reality and realize that the quantum reality behaves differently. Yeah.
Fully.
But it doesn't mean it's beyond understanding. I don't know if that's the way people use the word understanding often in that way. I think that's a bit misleading.
Thank you very much for your time.
Right. Okay, my pleasure. Yeah, it's been good fun. Thank you.